Hi everybody, my name is Salma and in this video I'm going to talk about geothermal energy. Well, what is geothermal energy? In general terms, geothermal energy consists of the thermal energy in the Earth's core. Thermal energy in the Earth is distributed between the constant host rock and the natural fluid that is contained in its fractures and pores at temperatures above ambient levels, and we can use that energy like a source of power. Geothermal fluids of natural origin have been used for cooking and bathing since before the beginning of the recorded history, but was until the 20th century that geothermal energy was exploited for industrial and commercial purposes in Lardello, Italy. To know more about it, we have to know what is inside the Earth. The interior structure of the Earth is a layer in spherical shells, like an onion. These layers can be defined by either their chemical properties. It has an outer silicated solid core, a highly viscous mantle, a liquid outer core that is much less viscous than the mantle, and a solid inner core. So, to find a place to be able to geothermal resource, the engineers have to take on mind these requirements. Accessibility. This is usually reached by drilling to depths of interest, frequently used conventional methods similar to used to extract oil and gas. Sufficient reservoir productivity. Ensure long-term production at economically acceptable levels. Thermal energy is extracted from the reservoir by coupled transport process. Typically, hot water or steam is produced and its energy is converted into a marketable product like electricity, process heat, or space heat. Many aspects of the heat extraction are similar to those found in the oil and gas. Because their similarities, equipment techniques and terminology have been borrowed or adapted for the use on geothermal development. Engineered geothermal systems, or EGS, are engineered reservoirs that have been created to extract economical amounts of heat from the low permeability or porosity geothermal resources. EGS who recover the thermal energy contained in the surface rock by creating or accessing a system of open, connect fractures through which water can be circulated down injection well heated but contact with rocks and returning to the surface in production wells to form a closed circuit. There are several options to utilize the thermal energy produced from geothermal systems. The more common is the vast load electrical power generations. Basic binary power plant, if used when the water that is reaches from the surface is not hot enough to produce steam. The hot water is fed into a heat exchanger. The heat from the water is absorbed by a liquid such as isopattern, that is a liquid extremely volatile and inflammable, which boils at a lower temperature. The isopattern steam is used to drive turbines producing electricity. Isopattern then is condensed back to its liquid state and used again. Single flash power are the most common from the geothermal power plant. The hot water is pumped under the grid surface. When they reach to the surface, the pressure is reduced, and as a result, some of the water changes to steam. This produces blast of steam. The cooler water is returned to the reservoir to be heated by geothermal rocks again. Type of expansion power plant produce electricity directly from the that emerges at their surface. The steam drives the turbine. In specific cases, the ranges of the EGS resource types and applications. Electricity generation using EGS have fluids from sedimentary and basement rock formation and similar reservoirs. Electricity generation from the co-produced oil and gas operation using organic binary power plant. Combined heat and power. Cogeneration of electricity and thermal energy. Well, there are engineer design analysis to know which is the best way to use the geothermal energy. First is identification of the most appropriate conversion system, calculation of the net power per unit area of map flows and geofluid, estimation of capital and installed plant cost, environmental attributes of EGS. When examining the full life cycle of geothermal energy developments, their overall environmental impacts are lower than the conventional fossil fuel and nuclear power plants. This is primarily because a geothermal energy source is contained underground, and the surface energy conversion equipment is relatively compact, making the overall footprint of the entire system small. Geothermal power plants operating with closed slope circling also provide environmental benefits by having minimal greenhouse gas and other emissions. With geothermal energy, there is no need to physically mine materials from the surface resource or to modify their subsurface to a significant degree. There are minimal discharges of nitrogen and sulfur oxides, particulate matter resulting from its use, and there is no need to dispose of radioactive materials. However, there are many disadvantages of using geothermal energy. One of them is high installation costs to get the geothermal energy situated to a particular relation. It is only sustainable for regions which have hot rocks below the earth and can be producing steam over the long period of time. May release harmful gases. Geothermal sites may contain some poisonous gases, and they can escape deep within the earth through the holes drilled by the construction. Transportation. Geothermal energy cannot be easily transported. Once the tapped energy is extracted, it can be only used in a surrounding areas. Economic impacts. General geothermal power is a low-cost energy source that diversifies the fuel supply and benefits the transition in power grid. The average cost of geothermal plant over its life is dramatically lower than the traditional source of power. Geothermal energy is locally producing, reducing foreign or oil imports, and boosting the rural economies. Geothermal power project development will involve hundreds of individuals, employing local people full-time as well as stimulating induced jobs. A Newberry volcano project is a very important plant of geothermal energy that is located in the central Oregon, and this project was made from the people from the Massachusetts Institute of Technology and 2005. If you like this video or you are interested on geothermal energy, you can check this reference to know more about it. Thanks for watching.